Hello YouTube, it's Jessica from STEM AP guys. Welcome to another tutorial. In this tutorial, we're going to continue where we left off in the last tutorial. As you remember, in the last tutorial, we were able to take an image or any data for that matter from our Raspberry Pi, and we were able to, before we do that, open a listener in our computer, our desktop, and it's going to open a listener on port 2025, and then you go into your Pi, run this command, and it's going to bring an image from the Pi into your desktop, right? And you don't have to open it, you don't have to know to do anything, and it's going to keep sending images as long as that is open. Okay, we accomplished that using Socat and using Bash scripts. In this tutorial, we're not going to do that. We're going to use Rust. So what we're going to do is, I'm going to close this and I'm going to show you. Actually, this is the book that I mentioned. We're going to be doing five. If I mentioned this in another tutorial, we're going to be working with pipes and FIFOs. Okay, so that's what's, if you want it, this is a great book. I recommend it. This is what's happening. This is what we're doing. So how do we do that and how it works? First of all, let me close the server. And now let's, before you do that, you have to open the pipe. And basically, let's just go back a little, 1 minute. Socat, the way Socket works, it bridges different types of connections. So you can do a pipe, or you can do, in our case, we were coming from the Raspberry Pi into our computer. So we were putting, so we, instead of using that, we were using the transmit bin binary, if you remember, and then the target, whatever target it was my Mac, right? Because we were sending stuff from the Raspberry Pi into our computer. When you're doing Rust, you don't need that. You don't need that intermediaries tool like Netcat or Socat, because Rust is a systems level programming language like C, C++, and what it does is working close to the metal, and it has access to the IPC, to the standard FS, and I'm going to go over that through open options, but it also has access to the TCP, so through the standard net, and we will do that in the next tutorial. In this tutorial, we're going to talk about IPC and FIFOs and how to do it using Rust, because they can be very handy. Trust me. And for those of you who do not know what a IPC is, it's the inter-process communication. This is working at the OS level. And besides FIFOs, it also has Unix domain sockets. Do not confuse those sockets. Those are not the same sockets that we use. These are Unix domain sockets at the IPC level. They're different, but it uses semaphore, share memory, and all of that. This is all at the operating system OS level. It works with at the FS level using kernel space and the BFS layer. And the way it works, you open a loop, you create a loop, open a pipe, read or write into that pipe, close that pipe, and go to sleep. Basically, what you do is one process says hello, it goes into the kernel buffer, and then it shows up for the process B to be able to read it. And then it reads hello. And I'm going to show you now. Before, you have to create the pipe. This is what I'm doing here, is make FIFO. And then you give the whatever pipe you're going to use and whatever other pipe you're going to use. It's gotta have two, right? just like he has here, 1 and 2. So that's what's happening. Okay, so stuff is gonna come into the pipe and go through the buffer, like I just showed you, and then the other process is gonna be able to read it. Okay, and if you want to get more into detail, how's that working under the hood, you can go here and really go into it. He's using C, but all of that stuff also applies to, it's very similar to what we're doing here with Rust. So basically that's what I'm going to do now. I'm going to hit enter, and I already have it open. It's telling me, it's complaining, saying, dude, you already have one open. So now I'm going to enter the other command, which is this command. This is going to run, not this guy, but this guy. And it's going to run, and I'll go over the code in 1 minute here. It's going to run this code. So that is that. It's that the binary, and it's going to go from pipe 1 to pipe 2. But so now we create 1. And cargo run. Why is it not running? And then it opens the pipe. And as you can see, it's right there, chat pipe 1. And then we got to open another layer, another terminal, and do the same thing. But instead of pipe 1 to 2, it's going to be pipe 2 to 1. So we hit enter, and now it opens the second pipe, the second chat box, or the other end of the pipe, whatever you want to call it. So now you have stuff coming in, and then it's going to go out. Okay, so now we go hello, and it's here, he reads it, right? Hello, how are you? He reads it, and there it is. And then that's a chat box in Rust using FLTK, and you can make that really pretty. If what you need, a lot of times you need IPC, especially if you're using networking, if you're doing certain things, you need this stuff. So this is the beauty of using Rust, because you're able to have access. In the next tutorial, we're going to be talking about the TCP, how to do it not only local, because this is local right now. This is all local on my computer. But sometimes you don't want to work on your computer. You want to use the Raspberry Pi like we did with the other tutorial, or whatever network out there. And you need to use the TCP pattern, which is at the network level. But we're going to do that in the next tutorial. Let's just concentrate now on the IPC and FIFOs. So let's look at the code. What is going on here? In order to produce these nice chat boxes, we need FLTK, right? We need the FLTK Rust, and this is what I'm bringing here. And by the way, the cargo toml library, the toml file, this is what it looks like. For these, don't worry about some of this stuff. This is from other tutorials. For these, you need FLTK. I believe you don't need any other stuff. Oh, you need no. You might need image, but it will complain. So if it's not there, just add it. But remember, I'm gonna put that on my GitHub so you'll see it. And that's the Internet Protocol Suite for those of you who forgot what it is. Let's continue. So here, in order to create this box, you need a app that it manages the whole application, right? It manages the FLTK app. The button, you need a button. The pack is just a layout container to organize all the widgets. That's what that is. So that's what that input is, a text input field for the user input. Prelude, it just makes it easy to import all the traits that you need for the full text widgets. Text buffer and text display is going to store the text content for a text display, which is this guy right there. And this is read-only text display widget. That's all it is. And the window is the whole window. It represents the main application window. In this case, this one. This is the magic. What makes happen is of coming from the standard, you're getting open options. That's the power right there of Rust, is access to the IPC is done through here. It allows the opening of file with different read and write options. The IO input output, it allows you to read and write operations on files. The thread, we're going to be dealing with different, so there's different threads being spawned. So you need to bring thread. Here, the time duration is remember that when you open a pipe, you close the pipe and then you go to sleep. That's what's happening here. You need time for the duration. This is the struct that we're going to implement down here. It has the window, the input, the button, all of that good stuff, same stuff here. Now it's going to be implemented. So when we get into the implementation, the constructor new method is going to be, you see here, is going to be a chat. That's going to be the string, because that's where that is coming from. And just in case you don't see it, let me open it here. It's going to be the name, and it's going to have whatever you're using. In this case, it will be temp1, temp pipe 1. In this case, it will be chat temp pipe 2. That's where that is coming from. And we continue. Is going to be here, the window, it creates a window 100, where is it? Here, 100 by 100 and 400 by 300 pixels. If you've seen some of my tutorials before, you've seen this a million times. This is what is create the layout container to arrange all the user interface elements. So that's what's happening there. You have a spacing of 10 to make it look pretty. Here is the display buffer, that it creates the text buffer that is going to be associated with the text display. These two guys are working together. And basically, it's this is doing the cloning so you can use it, the inputs and the buttons, and then it starts the window and it shows the window. So that's what that is. Here, as we continue, this is when all the UI stuff is initialized, and it's going to have the read pipe and the write pipes, and then you're going to have read pipes, write pipes. And basically, it's going to be all, this is where the stuff, the messages are going to be being written via the FIFOs, right? So that's what's happening. It's going to be printing opening pipes. This is what you see right here, opening pipes, read from, whatever the argument is, write to, whatever argument it is, that's what's going on there. Writing, this is the callback with the closure, and it's making sure that it's not empty. And then it's going to, once it knows that it's not empty, it's going to write the message. And it's going to basically send it down the pipe. And it's going to append this me. That's where that's coming from. You see it's appended. And here, other is also appended right here. That's where that's coming from. It's appending the message. The input set value is going to input whatever the value is at. Set up the read pipe. Now here we spawning the first of our threads and doing the same thing again, but on the other side, right? It's basically the same thing here, but on the thread on the other box, right? Wherever it's happening, coming from. And here it's going to sleep for 100 milliseconds. It's going to pause to make sure that everything it looks the way it should look. Basically, make sure that everything worked. It's going to be the input is going to input handle for the events, whether it's key down, whether you stop. This is where all the event handling is taking place. It's another callback, right? And it's using the stuff that we imported from the FLTK. And that's what is happening here. Well, this self, this is a while loop, infinite, as long as it's open, it's gonna keep going. And basically here it's just letting you know through the main function the usage. So it's telling you that it needs 3 arguments. That's why we imported these for the arguments. It's going to collect the arguments. It's going to tell you if it's not equal to 3 arguments, it's going to complain. And what are these 3 arguments? Let me just show you. These are these 3 arguments. 1, 2, and 3. Name of the file, pipe 1, pipe 2. So it's going to have, and if you mess up or you didn't do what you're supposed to tell you, for example, if I leave one out, it's going to tell me, uh, it's going to complain. It's going to tell me, dude, you're not reading the instructions, do this. And if you forgot to create the pipe, it's also going to tell you. But that's what basically it does. It does, like I said, this can be very handy for certain applications. And I, uh, I for us, if you need IPC and you need FLTK, you can use this. I'll put it on my GitHub and use it to your heart's content. This is the end of this tutorial. If you like this tutorial, please click the like box, subscribe to my channel, and I will see you next time with another tutorial. Take care.